Hello friends, welcome to the EduSat Network. Our today's topic of discussion is indoor air quality and health, and for this discussion we have with us in the studio Dr. Arun Srivastava, Assistant Professor, School of Environmental Studies, Jawaharlal Nehru University, New Delhi. His specialization is air pollution, both indoor and outdoor, and he has a 12 years of research experience. So with this, I would like to welcome Sir to our EduSat studio and request him to begin our today's lecture. Thank you for coming,
Thank you very much. Good afternoon, everyone. Today I am going to speak on indoor air quality and health. We all know air pollution. We have heard so much about air pollution, but whatever air pollution we had been hearing so far is mainly concerned with the outdoor air pollution. But we cannot ignore the indoor air quality, and it is becoming very important. In fact, it is very important because most of our time is spent outdoors. I must start with some introduction. This EPA and WHO has ranked indoor air quality as one of the top most 5 risks for public health. And the major reason behind this is that we spend 90% of our time mostly indoors, and since sometimes what happens, the pollution level in indoor environment is higher, significantly higher than that of outdoor environments. Therefore, this indoor air quality becomes very, very important. Now, the presence of particulate contaminants in the indoor environment is of concern because most of our time is spent outdoors. In Delhi, it has been estimated that about 58% of Delhi's time is spent at his home, while 32% of his time is spent indoor elsewhere, maybe it is office, school, or for some activities, while just 10% of his time is spent is outdoor environments, thus making total 90% time is spent indoors, while just 10% is outdoors. Above all, one more important thing why we are concerned about indoor air pollution is it can be clear by this picture. If we presume a 35 cubic feet area volume, we will here you will see the situation in a clean environment, clean air, when there is no particulate contaminants. Will find just one particle in a 35 cubic feet volume, while if we go to the outdoor environment, it is presumed that the particle number can be increased or can be up to 1 million in 35 cubic feet, while if it is indoor environment, the number of particles significantly increases and can reach up to 100 million. So there is a very significant difference between clean air to the indoor air and between outdoor air and indoor environment. Now, the question is where these contaminants come from. There are different two types of sources where it can come from, that is outdoor sources and indoor sources itself. Now, what are the outdoor sources? Outdoor sources are mainly road and soil dust, automobiles, that is vehicles basically, local burning, and industrial. Why outdoor air is very significant as far as indoor environment is concerned? There are some reasons. If the indoor, it depends upon the conditions of indoor environment, like the permeability of the structure. I mean, what type of structure is indoor environment is made up of, number one. Number two, what is the stability of pollutant? I mean, if the pollutant is stable enough that it can sustain in the outdoor environment, so the chances are there in due course of time it will come to the indoor environment. The third one is indoor and outdoor exchange ratio or the rate. If it is high, I mean exchange rate is very, very high and outdoor air is polluted, definitely the indoor environment will be polluted. So these are the 3 things which are very important for the outdoor air pollution in connection with the indoor environment. They are permeability of the structure, stability of the pollutant, and the indoor-outdoor exchange rate. Now, what are the indoor sources? I mean, there are some sources which is in indoor environment itself. They are like this. One is chemical released from modern buildings and furnishing materials. Second is combustion gases from fireplace, kitchen, etc. chemical fumes from paints and solvents, molds and bacteria, and the last one is chemicals from cleaning products. It is not the end, still there are many sources like cigarette smoke, animal hair and dander if someone is having some pet animal. After all, it is garage from where the carbon monoxide, a very significant amount of carbon monoxide can be included in the indoor environment. Gases including radons seeping through foundation. I mean, foundations are made up of modern building material which might contain the radon which can seep into the indoor environment. Then radon from the insulating material. We are nowadays, just to make the air conditioner very significant, we are using the insulating material and that contains the radon. Apart from that, the particles which are already there, already present in the indoor environment, they can be re-entrained or re-enter into the indoor atmosphere. Now, here are some pictures of the indoor sources, indoor pollution sources. One is the kerosene heater you can see, then the gas stove, car exhaust from the gases from the garage, fireplaces, gas heaters, particle boards, I mean it is used for the making of ceilings, plywood, paneling of doors etc., room fresheners, paints and varnishes, and various type of solvents. Apart from these, there are some biological sources too. They are the molds and ceiling and the walls of the walls, molds on the ceiling and the walls, then the molds which is there in the closet, molds in the air duct and molds on the wall. The fact is that we rarely look onto these portions, and these portions in due course of time keeps on contaminating with the biological agents. So afterwards they become the source of the indoor pollutants, indoor biological pollutants basically. Now I'll show you how the particles which are present in the indoor environment are significant. There are range of particles. It starts from ozone, VOCs, ETS, that is environmental tobacco smoke, soot, that is basically unburnt carbon, atmospheric dust, viruses, oil smoke, sinking smoke, bacteria, house dust and mite, allergens, spore and pollens. It is segregated here on the basis of their sizes. The indoor particles, the size range of indoor particles can vary from 0.001 micron to up to 1000 micron. That 1000 micron is approximately equal to 1 micron. So we can say that particles might vary from around 10 to the minus 4 micron to up to 1000 micron. And here the smallest particles are basically gases. They are ozone, VOCs, some which is from 0.001 to approximately 0.1 micron. They are basically combustion products like atmospheric dust, soot, environmental tobacco smoke, and viruses, although it is not the combustion product. Afterwards, the particles which are between 0.1 to 10 micron, they could be bacteria, house dust, I mean biological origin particles. And afterwards, some particles which are between 10 micron to up to 1000 microns, they are again biogenic particles. And here the particles which are varying between 0.001 micron to up to 0.1 micron, they can't be seen by bare eyes. For that we have to apply some very specified instruments like a scanning electron microscope. And the particles which are varying between 0.1 micron to up to 10 micron, they also can't be seen by bare eyes. For that we'll have to apply some microscope, although compound microscope is enough to visualize them. But the particles which are basically of biological origin like molds, spores, etc., and they are between 10 micron to up to 1000 micron, they can be visible by bare eyes. Now why this is important? Because we breathe, we inhale the oxygen, and with that oxygen we take many particles, and the particles can be of varying type. It has different chemistry, it can have different biology, it can have various type of physics. So what happens when it goes into our body? The particles are, it is not that all the particles keep going inside our body or into the lungs etc., but they might. Our body has a very beautiful mechanism for its filtering. The particles which are very heavy or very large, they just go up to the upper portion of our respiratory system, and from there by sneezing etc. it can come out. But those particles which are of medium size that is said to be fine particles, and that can vary from 0.25 micron to lesser, 2.5 micron to lesser, they can go up to the respiratory tract, and there it is not very easy for them to come out. So what happens, they can settle there for some times, but obviously it can come out after in the form of mucus, sneezing etc., or it can go into our digestive system. From there it can be filtered. But those particles which are very fine, what happens to them? They basically get absorbed into our lungs or ultimately into the tissues, and in due course of time it can be even incorporated into the bloodstream. What are the outcome? What are the bad effects of this? It is given in the left hand side. Initially we can have many short-term problems like headache, dizziness, irritated mucous membranes, increased risk of getting a cold, allergies, asthma, lungs diseases, and skin irritation. Here again it is shown very nicely what happens in the upper portion. You will see the nasal cavity, oral cavity, and pharynx. These are the portions where the larger particles, or mainly the biological particles, can get deposited. So usually in winter season we feel so much problem, especially those who are allergic to the biological problem or those who are asthmatic. But the middle portion, which is basically trachea etc., there the particles of medium size range get deposited, and the final particles can go up to the lower parts of our respiratory system, that is basically alveolar sac etc. It is given in the right hand side, and it is again magnified in the upper right hand side, where the particles are the process of these particles to be absorbed into the tissues and blood stream are very significant. This is again a description of how the particles go into our tissues and how it can be deposited there. One more thing I would like to mention here, that the particles once deposited in the tissues or blood stream, from there it is more or less impossible for them to come out. So they are there to be forever, and there it begins their pathogenic, they in fact starts their pathogenicity, and it can sometimes, not sometimes, it can cause severe diseases. Sometimes it is long-term diseases, and sometimes it is short-term diseases. Again here the same thing is there. It is again divided into the different three sections, how it is deposited. The particles between 10 to 2.5 between 10 to 2.5 micron get deposited in the upper portion, and 2.5 lesser particles lesser than 2.5 micron reaches to the bronchiole or the lower part of our respiratory system. So now here it is again a kind of description. One more thing I would like to say here, that the particles which get deposited in the upper portion, there it get the chance to be soluble, because it is the portion where availability of water is very much in comparison to the other portion like medium and lower portion of the respiratory system. So there what happens, it over the time it becomes moist, and afterwards it's getting deposited or into again or it's breaking into finer particles, become more. So the chances are that from there it can go to the lower parts of our respiratory system. So what happens, the particles which are larger size, they initially impacts upon eyes, nose, pharynx and larynx. The particles which are medium size, they impact upon trachea and bronchi, and those particles which are very fine and which reaches to the lower portion of the respiratory system, they affect the bronchioles and alveoli. And what are the compounds which are the particles which are distributed in upper, medium and lower respiratory system? In the upper system, the particles mainly aldehydes, ammonia, chloride and sulfur dioxide, while the particles which the gases, especially the medium sized particles, that is ozone, they deposit in the medium portion of our respiratory system, while nitrogen dioxide etc., it can reach to the lower portion of our respiratory system. It was the type of sources from its origin point of view, And now I will discuss about the type of sources from its nature point of view. The particles which are in the indoor environment can be biological origin or can be of non-biological origin. So, we will discuss one by one. The particles which are of non-biological origin, what are they? They are mainly asbestos. First is asbestos. What is asbestos? Asbestos is basically a group of impure hydrated silicate minerals which occur in various forms. It is particularly used for insulation of electrical and thermal materials and is heavily utilized in pipes and boilers, cement board, thermal tiles, paints and wallpaper. And its acute exposure can cause skin irritation and lungs cancer, etc. Now, after asbestos, the next pollutant is carbon dioxide. Carbon dioxide is basically a colorless, odorless and tasteless gas. It is the product of combustion. It is a combustion product basically. And where it can come from? It can be originated from kerosene and wood or coal fueled appliances. Usually, the indoor CO2 concentration ranges between 700 to around 2000 ppm, but it can even exceed to 3000 ppm. It is the worst effect that it can cause is that it is asphyxiant and it can act as a respiratory irritant. Afterwards, it's carbon monoxide. Carbon monoxide is a odorless, colorless and again tasteless gas. It is again produced from the incomplete combustion of fuel. What happens actually, how it is produced? Basically the fuel, which is hydrocarbon mainly, is combusted in the presence of oxygen. So ideally when the temperature is optimum, oxygen supply is optimum and the combustion chambers environment is optimum, so there should not be production of carbon monoxide, but it never happens. Because of paucity, sometimes the situation is such that the oxygen is not optimum, it is lower, the temperature is again not optimum and the chamber is not very smooth, it is turbulent. So instead of production of CO2, CO starts producing. CO starts, it starts making CO, and CO2 is, that is why it is said that it is the product of incomplete combustion. And in domestic uses, it is used in water heaters, gas or coal heaters and gas stove. These are the indoor sources, but a very whopping outdoor sources are there of CO. What does it do? How does it affect? Basically, CO has a greater affinity for our blood, that is the one of the constituents of blood, that is hemoglobin. So actually hemoglobin actually should combine with the oxygen, and the oxygen afterwards gets carried to the various parts of our body. But CO has greater affinity with the hemoglobin than that of oxygen. So even a very small amount of CO is present in place of oxygen. So what CO does, it replaces the oxygen. Instead of oxygen, CO starts combining with the hemoglobin, and that hemoglobin actually is now get converted into the carboxylic globin, and that is a very dangerous substance. And instead of oxygen, this CO starts being supplied to the various parts of our body. What happens when it reaches to the brain? Brain gets a lower amount of oxygen, or we can say that there becomes the paucity of oxygen. So brain sends a signal to the heart, and heart, just in the search of oxygen or in the need of oxygen, start beating randomly or start beating with fast speed. So and that can cause severe damages to the various parts, including the heart. It is also called, that is why it is called as a asphyxiant. The next one is formaldehyde. Formaldehyde is basically a colorless volatile organic compound with a pungent odor. The primary source of formaldehyde are building materials such as board, plywood, resin, adhesive and carpet. As far as its concentration and their acute health effects are concerned, it is given in the next in this table. What happens when the concentration of formaldehyde is very low, that is around 0 to less than 0.05, ppm, and there will not be some effect. It cannot cause any effect. But when the concentration increases and it reaches between 0.5 to between 0.05 to 1.5 ppm, it starts giving some neuropsychological effect. When its concentration is between 0.05 to 1 ppm, then it is basically said to be order threshold limit. When it is between 0.01 to 2 ppm, it starts irritating the eyes. When the concentration is between 0.1 to 25, then it starts irritating the upper airways. When the concentration increases and reach up to 5 to 30 ppm, then it starts irritating the lower airways and it starts affecting the pulmonary system. And when its concentration is between 50 to 100 ppm, then some diseases starts. They are pulmonary edema, inflammation, and pneumonia. When its concentration is more than 100 ppm, then it can cause severe health effects like coma and death. The next pollutant is nitrogen dioxide. Nitrogen dioxide is basically a water soluble red to brown gas with a pungent acidic odor. It is formed from the combustion of nitrogen and oxygen during combustion. In fact, it has two different type of its origin. One is said to be because of the that is thermal NO2. Another is oxidation NO2. Thermal NO2 is produced when nitrogen and oxide combine at a very high temperature, and the oxidation NO2, it is produced when the nitrogen of fossil fuel gets oxidized in the presence of oxygen. So nitrogen dioxide has two different type of origin. Nitrogen dioxide is in itself is an oxidizing agent that can be very irritating to the mucous membrane of the lungs. It is highly soluble in water, and it is also said that it can combine with the water in the lungs to form nitric acid. Afterwards, the next type of pollutant is sulfur dioxide, SO2. Sulfur dioxide is basically produced by the oxidation of sulfur impurities during the burning of coal and other fuels that may contain sulfur. It is mainly produced near in the thermal power plants. It is not a vehicular product but industrial. And what happens, actually absorption of SO2 in the mucous membrane of the nose and respiratory tracts occurs as a result of its aqueous solubility. The next one is radon. Radon is a product of ETS, that is environmental tobacco smoke. So cigarette is the leading source of radon, and it has a very bad effect. Once it is inhaled, it can tend to remain in the lungs for a very long time, and if it is not removed from there, it can cause some very chronic effect, including cancer, etc. Afterwards, the respirable particles. Respirable particles are the particles which are having the diameter of up to 10 micron size. They can be respired actually. In fact, there are many particles, more than 10 micron particles and less than 10 micron particles, but here we are concerned with the less than 10 micron particle because they are the particles which can be inhaled in our respiratory system. What are the sources of these particles? It can come from the smoke of the fire, of the wood and fossil fuels. It has both chemical and physical characteristics as well as toxicological properties. Physical is shape, size, its biological origin, etc. And chemical is basically its chemistry, the type of elements it might contain. One of the primary constituent of the smoke are respirable particles. These are aerosols that are of small enough diameter to enter and remain in the lungs. Many of them are around 6 to 7 micron or less in diameter. The particulate matter comprises of a mix of organic and inorganic substances, including aromatic hydrocarbon compounds, trace metal, nitrates, and sulfate. This can cause severe respiratory illnesses. The next one is environmental tobacco smoke. What is environmental tobacco smoke? It is a kind of aerosol containing several thousand substances that are distributed as particles, vapors, and gases. Environmental tobacco smoke, or ETSS, is possibly one of the most important indoor air pollutants in homes and offices. The most common acute health effect and associated with exposure to ETS are eyes, nose, and throat irritation. Various substances that can be emitted from one cigarette smoke are given in the table here. You can see so many compounds, starting from carbon dioxide. The units are there in microgram per cigarette. So it can vary from 10,000 microgram to up to 80,000 microgram. Basically this variation is because of the type of cigarette one smokes. Then carbon monoxide, it can vary from 500 to 26,000 microgram. And the oxides of nitrogen, these oxides are basically nitric oxide and nitrogen dioxide. It can vary between 16 to 600 microgram. Ammonia, that is 10 to 130. Hydrogen cyanide, 280 to 550. Formaldehyde, 20 to 90. Acrolein, that is 10 to 140. And nitrosodium methylamine, that is 0.004 to 0.18 microgram. Nicotine, that is 60 to 2300. It is not the end. Still there are total particulates, that is between 100 to 40,000 microgram. Phenol, catholol, naphthalene, benzopyrene, aniline, 2-naphthalamine, 4-aminobiphenyl, N-nitrosonogrenotine. Now, in this picture, we can see what a cigarette can be compared with. It emits cadmium, which is used in batteries. It emits stearic acid, which is a kind of candle wax. It emits toluene, that is a kind of industrial solvent. Nicotine, which is basically a insecticide. Ammonia, that is a toilet cleaner. Methanol, that is used in rocket fuel. Carbon monoxide. Arsenic, it's a kind of poison. Methane, that is a kind of shiver gas. Acetic acid, that is vinegar. Butane, that is lighter fluid. So these are the compounds that one cigarette can contain. It can't only affect those who smoke, but can be a reason for the elevated indoor air pollution. Afterwards, the next one is volatile organic compounds. What are volatile organic compounds? Volatile organic compounds are organic compounds having a boiling point that can range between 50 to 260 degrees centigrade. Exposure to VOCs can result in both acute and chronic health effects. Concentration of VOCs found in indoor air are provided in the following tables. These are the type of VOCs that can be anticipated in the indoor environment. They are benzene, toluene, N-decane, limonene, O-xylene, 1,1-trichloroethane, P-dichlorobenzene, 1,2,4-trimethylbenzene, M and P-xylene, N-decane, 1,3,5-trimethylbenzene, dichloroethane, trichloroethane. Now, here it is given some of the indoor air pollutants and their sources. In fact, we have already discussed it. There are again some. Ozone is basically it's a product of photochemical reaction. Now, what is the percentage of major pollutants of outdoor environment, and that can be a cause of indoor environment? They are benzene, that is industry contributes 32, while transport contributes 65. Carbon monoxide, industries contribute 3, 90 transport. Lead is 31% is contributed by industries, while 60% is contributed by transport. While oxides of nitrogen, 38% is contributed by industry, 49% is contributed by transport. Particulate matter less than 10 micron, 56% is contributed by industries, while 25% only is contributed by transport. Sulfur dioxide, 90% of indoor sulfur dioxide can come from industries, while 2% from transport. While volatile organic compounds, 52% by industries and 34% by transport. What are the indoor pollutants of biological origin? They are bacteria, fungi, and viruses. A large number of species of fungi and bacteria are found indoors where they are associated with presence of various organic matter. Here it is a picture of dust mite. It is also a kind of pollutant that can be seen in the indoor environment. Then this is the picture of viruses, fungal spores, bacteria and pollen. These can be the part of indoor air pollution. Now, in indoor environment, in general, what we can anticipate the contribution from various type of pollutants. Particulate can contribute about 34%, 35%. Bioaerosols can contribute around 34%, while organic compounds can contribute around 31%. And in the right hand side is given the various type of diseases that can be caused. It starts from cancer, kidney, liver damage, skin rashes, development problem in children, nervous system damage, cough, throat infection, birth defects, miscarriage, etc., asthma and chronic bronchitis. Here it is what happens. What is the it is given the picture of a asthmatic patient. What happens actually here, you can see the how the airways are blocked and they are narrowed down. One is normal bronchiole, another is asthmatic bronchiole. It is yet not clear that whether it is this asthma is caused by air pollution, indoor or outdoor, but it is certain that if someone is asthmatic, he or she can have, this his or her severity can increase if the environment is polluted. Now, I'll show you some salient features of indoor air pollution. One is sixth building syndrome, that is also known as SPS. What is SPS? SPS is basically any combination of symptoms that you can feel after entering a polluted building, and these symptoms tend to disappear after you leave the building. But what happens? These symptoms, you start feeling these symptoms as soon as you enter into the building. So within a second or so, but it is not easily disappeared. It might take a significant amount of time in disappearance. Again, it is said that people can tolerate a problem when it is hot, humid or noise, but it is not the condition of SPS. So what is SPS basically? SPS is they only make us less tolerant of any particular level of indoor air pollutants. The SPS is primarily caused by the combined action of many chemicals released into the air by different processes. So SPS, the main responsible factor of SPS is the indoor air pollution. What are the symptoms or what are the effects of SPS? It is headache and nausea, nasal congestion, chest congestion, eye problem, throat problem, fatigue, etc., chills and fever, muscular pain, neurological problems, dizziness and dryness of the skin. The next one is multiple chemical sensitivity. What is multiple chemical sensitivity? Some people have developed severe intolerance to chemicals which they have previously tolerated very, very well. When people develop a rash on exposure to a chemical, we usually say they have an allergy. When people develop wheezing on exposure to a chemical, we usually say they have a form of asthma or allergy to that particular chemical. When people develop headache or fatigue or confusion or other unbearable symptoms on exposure to a mixture of chemicals, we say they have multiple chemicals sensitivity. It means that the people might be tolerated to one chemical, he can be tolerated to another chemical, chemical number 2, he can be tolerated to chemical number 3. But when he is exposed to all these chemicals together or any two of the chemicals together, he cannot tolerate it. That is known as multiple chemical sensitivity. The next one is personal cloud effect. What is personal cloud effect? Personal exposure to many pollutants can markedly exceed those anticipated from concentration in the ambient air. This is known as personal cloud effect. It means that the level of pollutant of some particular pollution can be significantly higher than that one can anticipate in a worst outdoor environmental condition. How these problems can be taken or how to overcome these problems. So first of all, we have to identify the source and we should try to eliminate it the problem at the source or the release of pollution from the source only, or otherwise we can have a airing effect. I mean, the particle, when this effect is it becomes very significant, this particulate contamination can significantly be reduced, and the pollen etc. can also be we can overcome those things also. Apart from that, we can use good quality of air purifiers, and apart from that, we can have some additional measures like encasing for bedding and mattresses, vacuum cleaner, these things, and HEPA filters can help in significantly reduction of the indoor air pollution. So these things can have some better effect like prevention of allergies to the children, delayed of the occurrence of an allergy to the children, as well as reduction of the symptoms of those allergy. What are the advantage to the people who are already suffering from these allergies? They can have reduced symptoms from these allergies, and often, I mean, they will not need to go quite oftenly to the hospital or to see the doctors, and they can have more relaxing sleeps. We have carried out, we still have some time, I think.
Yes.
We have carried out some work here in Delhi. During my PhD work, I have chosen different 24 places for the sampling. In fact, it covers more or less the entire Delhi. It starts at, it is shown here in this picture. And the pollutants we measured the suspended particulate matter concentration, and it is shown here in the picture at the bottom center. The red one, the red bar, it represents the outdoor concentration, while the blue one represents the indoor concentration. Here we see no much difference between the outdoor environment, outdoor suspended particulate matter concentration, and the indoor suspended particulate matter concentration. And sometimes we have found the indoor suspended particulate matter concentration is significantly more than that of outdoor suspended particulate matter concentration, especially in the Wajidpur area and Ganeshpura area, then Connaught Place. Hauj Khas is more or less same. So we can't say that outdoor environment is always polluted than that of indoor, or indoor environment is cleaner than the outdoor environment. And when we correlated it with the various parameters, we have found that SPM between indoor and outdoor had a very good correlation. I mean, whatever the SPM we are anticipating in the indoor environment might be of outdoor origin, while the different metals, in case of different metals, copper, chromium, cadmium, and nickel, they had a good correlation, while magnesium, iron, manganese, and lead, they had an average correlation, and calcium had no correlation. It means whatever the calcium we are finding in the indoor environment, they have nothing to do with the outdoor environment, outdoor Ca concentration, while the Mg, Fe, Mn, Pb, etc., whatever the concentration we are finding in the indoor environment might be of outdoor origin. Some of that might be of outdoor origin. And we have also conducted the indoor to check the indoor air pollution of various kitchen environment, and we did sampling in kitchen environments of inside, in fact, in the JNU campus, various places of JNU campus, and it is given here in these pictures. We can see there is significant contribution of particulate matters in the kitchen, various type of kitchen environments. These, in fact, various kitchens where one is hostel mess, two are hostel mess, one was household kitchen, another was canteen, while another was a kind of dhaba. And once we did a sampling for a very prolonged period, that was for approximately 45 days, and it is shown here in the picture. We can see from this picture that there are some days or some moments we have when we are finding a very high concentration of indoor particulate matters, and it is sometimes exceeding more than 1000 microgram per meter cube. These are some of the morphological analysis of those particles. Here it is more or less we are finding more or less all type of particulate matters in the indoor environment. It includes soot particles, organic particles, biological particles, as well as the metallic particles. Again, we have carried out some analysis of bioaerosols, some biological particles also, and we have found a very good concentration of bioaerosols in various sites of GNU. It is shown here in this particular picture. These are the bioaerosols which we have actually observed. That's it. Thank you very, very much.
Thank you so much, sir, for giving us a very good insight into the idea of air pollution, which can also be indoor. We normally assume it to be outdoor air pollution, but many of us would not be knowing that there are so many adverse effects of air that gets polluted within the domain of the household, and what are the various things that we can do to take care of this. And certainly we keep our houses clean, and we do not realize that the air may not be so clean because of simple things such as even cooking, or even if we heat the oil too much, and other things like molds.
Yes, yes.
As sir has mentioned. So I would briefly like to ask you a question. Say, you had mentioned that the air can also become polluted because of radon that is used in the ACs.
No, it is not used in ACs basically. What do we do nowadays in the modern buildings? We use insulating materials. I mean the walls, etc. If you go to hospital or very modern buildings, you will find the buildings are not simple made up of cement, but some insulating materials. This is done so to keep the air or the temperature constant in the indoor environment. So in fact, those insulating materials we use, radon, etc. And the pipes, the pipes which are used inside those walls, etc. They might also contain radon. So these, in fact, this radon is very harmful.
Right.
And it can cause chronic diseases.
And these can be caught just by roaming in the mall, even if you're just walking around.
It depends upon how strong those insulating materials are, and what type of wearing and tearing is being there. I mean, it's tearing out of those walls and getting suspended into the air. That is important. If it starts getting suspended into the air, that can definitely cause harmful effect.
Right. So also, sir, you mentioned that cigarette is a very strong source of this gas.
Yes, yes. Cigarette I showed you in the picture. It might contain over thousands of different chemical substances. That starts many chemicals, different type of particulate matters, and some of them are carcinogenic and mutagenic. So cigarette, it is not that cigarette is injurious to the person who is smoking only. It is, in fact, it elevates the indoor air pollution level. I mean, if someone is smoking inside and he is causing definitely injury to himself, but he is in fact contributing to the indoor environmental pollution. So over the time, and this indoor pollution is not easy to be to overcome those things. So I mean, it starts this pollutant continues to be there for a very longer period, and whoever is there, he is prone to inhale and he is susceptible for those problems.
Right. Sir, in this regard, could you also tell us whether air purifiers are a good source or they are actually harming us?
No, air purifiers are good. I mean, if it is installed properly and it is effectively working, and air purifiers, one more thing for air purifiers are that they should be maintained properly. I mean, their servicing, etc. should be done continuously or regularly, so that they can effectively work. And air purifiers are, it significantly helps in reduction of the indoor air pollution.
Right, right. So with that, we would like to bring the lecture to a close, and thanks, sir, for being here and also talking about a very relevant topic that would be pertinent even to say a general viewer who is not a student of science, but in other aspects as well. So thank you so much, sir, for being here. We appreciate it, and thank you all for watching. Thanks a lot.